sensors going to produce the data. Okay, they have their own security protocols. Some industry standard security features which are going to include the some of the devices and the sensors for identification and authorization. Okay, and data encryption, and some platforms we are going to use which are having we have the trust in that particular module, which enables self destruction when the sensor is physically handled, and the user ID authentication and the authorization. Okay, that is very important because we are talking about the security. Whenever the security comes in a picture, we always think of the authorization and the accessibility of that particular things, right? So we are giving much importance for the authorization and the authentication of the data, right? So sensor identification and authorization typically requires a pre-installed factory X.509 certificate and public key infrastructure, that is PKI, at the organization level, where new certificate is installed through a zero touch deployment process. Okay, this additional process may slow on deployment, but ensures that security of the particular changes only we are going to do it. So where a new certificate is installed through a zero touch deployment process, right? That is done through the public key infrastructure, that is called as a PKI. Another consideration which we are going to type of the data that sensor is going to produce, what kind of data is the sensor is able to produce it. Okay, then, and for example, if you take a roadside car counter may include a Bluetooth devices, right, which is going to be uniquely identify each driver or the person who is walking on the pedestrian. Okay, then so sensor identification authorization are, as we have discussed, and this smart city security architecture is gives information about the city layer transport data between the street layer and the data center layer. This city layer plays very important role in transferring the data from the street layer, where the producers are going to produce the data, that is the sensors, right? And that data should be transported to the data center layer, where the aggregation of the data and the normalization of the data will be done. It acts as a network layer. The following are common industry elements for security on the network layer. Firewall is located at the edge, and it should be IPsec and the VPN ready, and which include the user and role-based access control. It should also be integrated with the architecture to give city operators remote access to the city data center. So VLN provides end-to-end segmentation of the data transmission, further protecting the data from rogue intervention. Each service or domain has a dedicated VLN for data transmission. Encryption. Protecting the traffic from the sensor to the application is a common requirement to avoid data tampering and waves dropping. In the same cases, encryption starts at the sensor level. In some cases, the sensor starts at the gateway link uses one type of encryption, and the gateway to the application connection uses another encryption. For example, we can say VPN. So that is about the smart city architecture. In the fifth module, right? If you have any doubts, you ask me in the fifth module. That completes your whole syllabus. In the fifth module, what you are going to study about the Arduino UNO, right? Then that is IoT physical devices and the endpoints. Arduino UNO, we understood. Introduction to Arduino, that is what is that Arduino, and about the what it is how it is going to helpful for us, and what it does, why we have chosen Arduino UNO, and what are its advantages, right? Next is we have studied about the installation of the software, right? How we are going to install the software, and fundamentals of Arduino programming. So what are the different syntaxes and grammar of the Arduino programming, right? As I told, it is like a C language only. Only few syntaxes are going to be changed. Logic will be the same because the grammar of the language changes from Arduino programming to the C, but logic will be the same. And after Arduino programming, some different concepts have completion, right? So you are going to study the Raspberry Pi, about the introduction to Raspberry Pi, about the Raspberry Pi board, right? And what will be the hardware layout of the Raspberry Pi, okay? Then operating system on a Raspberry Pi, that is developed by Raspbian Foundation, right? Raspbian OS developed by Raspberry Pi Foundation, okay? And configuring the Raspberry Pi, programming with Raspberry Pi with Python, okay? Wireless temperature monitoring system using PIDS 18B20 temperature sensor, and even extra I did lightweight sensors, connecting Raspberry Pi via SSH, accessing the temperature from DS18B20 sensors, remote access to Raspberry Pi, and smart city architecture, connected cities, an IoT strategy for smart cities, smart city IoT architecture, smart city security architecture, and smart city use case examples. Okay, so if you have any doubts, you please do ask. This module is very easy. That is the fifth module is very easy because as we are a computer science students, we are able to, once you read, it is very easy for you to write the answers. Okay, don't neglect the fifth module. It is the most important module for your IoT network. Okay, so if you have any doubts, you just ask me, or some of you only tell me. Can you tell me some of the examples for smart cities? What are the requirement of the smart cities? Anyone? It may be related to the hospital, okay, or it may be related to the smart parking system, right? Okay, about all the automation systems that are going to be run through the IoT network in any smart city or metropolitan cities. Tell me fast. You have to answer it. If you keep quiet, what can I understand? So, or else shall I discuss your IA portion? Second IA portion, 1.5 module. That is half module of the module 2 and full module of 3. Second module is smart objects, right? And third module is about IP. Okay, I will do that one only. Okay, you people are not talking only. That is a problem. Not responding only. Wait, I will share that screen. Okay, you be on the line. So you are able to see the module 2 smart objects. Okay, that is there for your internals. So go through the topic. So we are going to connecting the smart objects. The characteristics and the attributes which are going to be considered for connecting the smart objects is the range. That is you are going to use what kind of technology, right? Whether you are going to use a short range, medium range, or the long range. Short range is comes under the Bluetooth devices. Medium range will come with the series of your 802.15.4 framework, right? And Zigbee devices, okay, and 802.15.11 ACBGN and the AH, okay, and 1901.2 PLC. These are all comes under the medium range connecting devices, right? And long range where we are going to connect the devices with a long range, it comes under the second gen 2G, 3G, 4G, okay, and the 5G also. These short range devices are classical wired examples is a serial cable, right? And wireless short range technologies are often considered as an alternative to the serial cable, which are going to support the 10 meters to of maximum distance between the two devices. And examples for short range wireless technology is Bluetooth IEEE 802.15.1 and 8.15.7 and the VLC, visible light communications. These short range communication methods are found only in the minority of the IoT installations, right? We use one very for less part of the IoT network, right? Bluetooth devices. And medium range is a range tens to hundreds of meters. Many specifications and implementations are available. The maximum distance will be less than 1 mile between the two devices, and the IEEE series of 802 point will be come under the medium range wireless technology, right, which are called as IEEE 802.11 Wi-Fi, 802.15.4 and 802.15.4G, that is a WPN, okay, wireless personal area network. And wired technologies like 802.3 Ethernet and 800 1901.2 and narrowband powerline communications, that is a PLC we call, that is a 1901, may also be classified as a medium range depending on the physical media characteristics, okay. And when you come to the long range smart objects, distances greater than 1 mile between the two devices require long range technology. Wireless examples are like cellular 2G, 3G, and 4G, and some applications of outdoor IEEE 802.11 and Wi-Fi and low power wired area, that is LPWA technologies we are going to adopt. These low power wide area communications have the ability to communicate over large areas without consuming much power. These technologies are therefore ideal for battery powered IoT sensors and found mainly in industrial networks. IEEE 802.3 over optical fiber and IEEE 1901 broadband powerline communications are classified as are all comes under the long range, are not really considered as IoT access technologies. Then frequency bands, radio spectrum regulated by countries and organizations like International Telecommunications Union and the Federal Communication Union Communications, okay, Committee, okay, then commission we call. These groups define the regulations and transmissions requirements for various such as radio, television, military and so on. So various frequency bands. So if you take that example, right, it comes under the radio, television, military and so on. When you are going to focus on IoT access technologies, the frequency band leveraged by the wireless communications are split between the licensed and unlicensed bands. Okay, when you think about a licensed bands, it is a spectrum generally applicable for IoT, okay, long range access technologies and allocated to communication infrastructures deployed by services providers, public services, for example first responders, broadcasters and utilities, right? And that is ITU, International Telecommunication Unit, has also defined the unlicensed spectrum for industrial, scientific and medical uh, portions, right, of the radio bands. For example, if you take a first responders, military, broadcasters and utilities, these frequencies are used in many communication technologies for short-term devices. Okay, unlicensed means that no guarantee or protections are offered in the ISM bond devices under the communications. I told you some of the they are going to use the unlicensed thing. Okay, that no guarantee or the protection offered in the ISM bands for the device communications in case of the unlicensed. Okay, for IoT access, these are the most well-known ISM bands, that is 2.4 gigahertz band as used by the IEEE 802.11 BGN Wi-Fi, and IEEE 802.15.1 will be the Bluetooth, and IEEE 802.15.4 will be the WPN. Unlicensed spectrum is usually simpler and deployed than licensed because it does not require a service provider. Some communications within the ISM bands operate in the sub-gigahertz range, right? And low power wireless area network technologies such as LoRaN and the Sigfox. The most well-known ranges are centered on 169 MHz, 433 MHz, 868 MHz and 915 MHz. The 868 megaband is applicable for to IoT access technologies such as IEEE 802.15.4 and G and AH, and the lower that is the low range wide area network. And the power consumption of these will be all battery powered nodes bring much more flexibility to IoT devices because they will not depend on the external sources of power. So if they are going to depend on the external sources of power, what happens? If power goes down, then your network issue will come. That's why normally all the IoT devices and the smart devices embedded with a battery, and they make that those components to work under the battery voltage itself, right? That is the minimum voltage or the maximum voltage that those components can use it, right? If it is going to use the accessibility of the power source from the external, so if power goes means there will be a network issue where again it is the network disrupted and it start taking the some other part. Okay, that is the reason why that is going to be uh, battery powered nodes are bring much more flexibility to the IoT devices. These nodes are often classified by the required lifetimes of their batteries, and powered node has a direct connection to a power source, and communications are usually not limited by power consumption criteria. IoT wireless access technologies must address the needs of low power consumption and connectivity for battery powered nodes. This has led to the evolution of a new wireless environment which is known as low power wide area network. So what is the topology we are going to use for these devices? So normally, as I discussed in the previous classes also, this IoT network is better topologies are star topology and the mesh topologies, right? Normally, almost all the IoT devices are going to use the mesh or the star topologies. Okay, so they are very flexible for the information to be transferred. For long range and short range technologies, star topology is prevalent, okay, as seen with cellular and low power wide area and Bluetooth networks. Among the access technologies available for connecting IoT devices, three main topology schemes dominate: star, mesh, and peer-to-peer. I told now, star and mesh are the best topologies for this IoT network, for where the distribution of the data will be moving on to all the devices. Okay, and for medium range topologies, a star, peer-to-peer or mesh topology is common. Okay, and peer-to-peer topology allows any device to communicate with any other device as long as they are in range of each other. And peer-to-peer topology cable more complex formations such as mesh network topology. See here the different topologies: star topology, mesh topology, peer-to-peer topology. Okay, so with the one which is going to be represented in the dark is a full function device, and one with a light reduced function device. The disadvantage of these sub gigahertz frequency bands is their lower rate of data delivery compared to the higher frequencies. Example, we can take indoor Wi-Fi deployments are mostly set for the nodes forming a star topology around their access points, APIs. Okay. Outdoor Wi-Fi may consist of a mesh topology of the backbone of APIs with the nodes connecting to the APIs in a star topology. IEEE 802.15.4 and G, and even a wired IEEE 1902.2a PLC are generally deployed as a mesh topology. Mesh topology requires the implementation of the layer 2 forwarding the protocol known as a mesh under, or layer 3 forwarding the protocol referred to as a mesh over. On each intermediate node is going to work it. So come to the constrained devices. Constrained devices are limited resource that impact their networking feature set and capabilities. Constrained nodes can broken down into different classes like which are shown in the table, that is the class 0, class 1 and class 2 devices. Constrained node networks are often referred, they are also called as low power and lossy networks because their consumption of the power is only battery level, right? Okay, that's why they are called as a low power or lossy networks. Lossy networks indicate that network performance may suffer from interface and variability due to the harsh radio environments. Okay, layer 1 and 2 protocols that can be used for considered the network must be evaluated in the context of the following characters for the use case applicability. Data evaluated in the context of the following characteristics for use case applicability. Okay, data rate and the throughput latency can be determined, and overhead and payload. The IoT access technologies developed for constrained nodes are optimized for low power consumption, but they are also limited in terms of the data rate, which depends on the selected frequency band and the throughput. So IEEE standard 802 pointers of that framework they will ask, right? Okay, that is very important. So this framework they may ask, okay, they may ask you to write and explain this. Topologies. Just go through the topics of this module 2 of the portion, right? So if you have any doubts for your IA, just ask me. That is a module 3. This module 3 is about the IP and the IoT network layer, right? That is the IP as a business career and IP. And just go through this. All of you go through the module 3. All of you go through the module 3 notes. In these notes, actually, so see, I shared David.pdf one book in the MS Teams, right? you download that book and read for third chapter. So it is very nice book, and you can easily understand that book, whatever the content is there in that book also. Okay. So I uploaded in the MS Teams that textbook David.pdf. I request all of you to download that textbook and read for your main exams as well as IAS. Okay. If you have any doubts, you please ask me. This book is developed, that means written by some of the author from Cisco company, because Cisco company is all concentrating on the network, right? So see chapter 3, smart object, the things connecting the smart objects is the fourth chapter, and fifth chapter, that is a page number 149. Okay. And application protocols of IoT. These two chapters is for your module 3, 5th and 6th. You have to read from this textbook chapter 3, 4, 5 and 6. Okay. So if you read this book, it's very nice book. One second. Yes. Smart and connected cities. See here, smart city architecture, that notes is available in the this textbook, that is chapter 12. Okay. So 386 page number. So I will do one thing. Tomorrow's class I will do once again the smart city architecture from this textbook. Okay, some of the topics which are not included, right? So in detail we'll study the smart city architecture from this textbook. Okay. If you have any doubts related to Arduino and Raspberry Pi, bring it to my notice and learn. Those are very good and easy topics for our CS background students, right? So tomorrow's class, once again I will discuss about the smart city architecture. Okay. page number 385. So here smart city layered architecture. So here street layer, city layer, okay, city layer, see, then the data center layer. So here service layer. See now smart city architect, security architecture. Some use case examples, smart city use case examples. So these are the use case examples. That is a smart parking system, hospital management system, right?